Hi everyone. In this video we're going to talk about effective rates. We've previously talked about compound interest, and you've seen that interest can be compounded a different number of times per year depending on the situation. So one question that we might ask is, which of those different compounding periods would give you the most interest? For instance, if interest is calculated monthly versus daily, is there any advantage to one or the other in terms of making more money? So the amount of interest does go up as the number of compounding times increases, but it's not actually as much as you might think. Here's an example: $1,000 investment at 4% interest for 10 years. The difference between compounding yearly and daily is only about $11. So one thing that you can do to compare, so let's say you're choosing between two different bank accounts and one offers 4% interest and another offers 4.2% interest, but the 4% interest has a greater number of compounding periods, and the higher interest rate is compounded a fewer number of times. So when the rates are that close, sometimes you might be interested to know if the compounding would actually make enough of a difference to matter. So what we do is look at the effective interest rates, and this kind of levels out the differences between compounding periods so that we can accurately compare different investing opportunities like this. Alright, so here's an example. Let's suppose you have an investment of $5,000 at 4% for 1 year, compounded semi-annually. So what we'll do is find the compound interest first, and then what we're going to do is find the effective rate, and the effective rate is the simple interest rate that gives the same amount of interest after 1 year. Alright, so we have all these varying rates and compounding periods, but we're going to even them all out and look at the simple interest rate that gives the same amount of interest. Alright, so first of all, compound interest. Let's use that formula. And we'll use the one for the amount, the future value, and then just subtract the principal to find the interest. Okay, so the principal is $5,000. Rate is 4%. Number of times per year the interest is compounded, well, it's semi-annually, so that would be 2. And then the time period is 1 year. Okay, try that calculation. And hopefully you get $5,202. So that would mean that the compound interest would be that amount minus the principal, minus $5,000, so $202. Alright, next we need the simple interest rate that gives the same amount of interest after 1 year. So we use the formula for simple interest, I equals PRT. We want it to yield the same amount of interest, so use 202 as the amount for interest. Still the same principal, $5,000. We're solving for the simple interest rate, and then we still want to consider a time period of 1 year. Alright, so to solve for R, divide by 5,000. Oops. Divided by 5,000. And let's see, that looks like 0.0404. So a rate of 4.04%. So the effective rate is 4.04%. Now let's compare with a second investment, and let's say you have the same principal and you want to invest for the same 1 year period, but you have a choice between that 4% rate and a 3.5% rate, which is lower. However, the interest is compounded monthly instead of semi-annually. So let's see if this makes a difference either way. Alright, so we'll do the same thing, calculate the compound interest by first calculating the amount in the account. Okay, and I'm just going to jump ahead and fill in the variables in the formula. Right, so we have principal. Rate now is 0.035. Your n, it's monthly, so that's 12. And raised to the power of 12 times 1. All right, so find that amount. And you should get $5,179, and I'll round to the nearest cent, so 90 cents. And that would mean that the interest is that number minus 5,000, so 179.90. Okay, and then we want to find the effective rate, so the simple interest rate that gives the same amount of interest. Okay, so I equals PRT, and then use the 179.90 number as interest, still a $5,000 principal, and then you're looking for the rate, and still a 1-year time period. Okay, so to find R, you divide both sides by 5,000. And let's see, that would be 0.03598. So about that's close enough. We can say 3.6%. All right, so it looks like the first investment is still better since you are earning a higher interest rate. And notice what we've done by comparing the two formulas, I equals PRT. We've used formulas that don't depend on n. We're just looking at a simple rate that gives that same amount of interest. So it's similar to if you look at standardized test scores. You have students all across the country, and in order to compare them, you kind of level things off and compare on some sort of a standardized scale. So that's what we're doing here. Now, there is a formula rather than trying to go through and calculate first the amount, okay, using the compound interest formula, and then finding the interest, and then going back and doing the simple interest formula. Instead, there's a single formula that allows you to find the effective interest rate right away. So what I'd like to do is just go through the formulas and show you where this comes from, and then do a few examples to actually use this formula to find the effective interest rate. Okay, so here's our goal. We want to get to this formula. All right, so if we start from the end and work backwards for the process that we did previously, the effective interest rate was found by I equals PRT, and then here this R, this is what we're now relabeling as E. All right, so if you solve this formula for R, divide both sides by the principal and time, then you get R equals I divided by principal times time. All right, now think about what we'd like to do, is to use this formula for E and just work with the information that's given in the problem in order to directly make that calculation. So if you look at this formula for rate, well, we are given principal in the original problem, that's good, and we're given time, but we weren't given the amount of the interest. That's what we found when we went through that whole calculation for A, and then we found the interest by taking the amount in the account and subtracting away the principal. All right, so what I need to do is rewrite this I in terms of information that's given in the original problem. So think about what we did to calculate that interest. We took the amount and subtracted the principal. All right, so I can substitute that in place of I. All right, so now that this piece is good, we know the principal that's given in the original problem. We're not given this amount, so I need to rewrite A and figure out what we did to calculate that amount. Well, we did the compound interest formula. We did principal times 1 plus R over N to the power of N times T. Okay, and all of that is A. And then you subtract the principal, divide by principal times time, and that's rate. All right, now notice we have two terms in the numerator here. I have this term, all of that's multiplied together. I have principal, and then I also have principal in the denominator. So when that happens, you can factor out this principal from the numerator. Okay, so I can rewrite this as principal times, all right, the rest of the amount formula minus 1. And then I can cancel out principal in the numerator and denominator. All right, another thing in all of these questions when we talked about effective interest rate, if we back up to the definition of what that is, okay, it's the simple interest rate that yields the same amount of interest after 1 year. So effective rate always uses a time period of 1 year. So in this formula, any place I see a t, I can replace that with a 1. So essentially that's basically going to cancel the t's out, right? If t is 1, that won't make any difference when you're multiplying or dividing. And what I'm left with is 1 plus r over n to the power of n minus 1. And the denominator on the fraction is just a 1 now. Okay? And then the only difference here, instead of calling this r, we've just relabeled this with e to show that it represents the effective interest rate. So that's where the formula comes from. And now let's try a couple examples of using this formula. Find the effective interest rate when the stated rate is 8% and the interest is compounded quarterly. Okay, so we have effective interest rate is 1 plus r over n to the n minus 1. Now the other nice thing you might notice about this formula is that it doesn't use any principal amount of money, so you no longer have to have a specific dollar amount in mind when you want to find the effective interest rate. All right, so that helps if you're comparing financial institutions, and you might have that question, well what if I invest more money? Would that make a difference for the interest rate? And we can see from this formula that the effective rate doesn't depend on the amount of money that's invested. All right, so let's go ahead and find this effective rate. We know that the stated rate is 8%. That's what we're going to use for R. The interest is compounded quarterly, so that's a 4 for n. Okay, to the 4th power minus 1. And if you use a calculator to find what that is, that's 0.0824 ... So we'll just go to a couple decimal places, maybe 2, that should be sufficient. And this was 0.082443. All right, so that's going to round to 8.24%. Okay, let's do a comparison. Which savings account is a better investment? 6.2% compounded daily or 6.25% compounded semi-annually? So to compare, we'll find the effective rates of both accounts and then just see which one is higher. Now if this was a loan, you'd want to see which rate was lower because that would be the more desirable situation. Okay, here's the effective rate formula. So for the 6.2% compounded daily, we have 1 plus 0.0625, and then n is 365. Okay, and then for the other one, the 6.25% semi-annually, oh, sorry, there's a mistake there. This should be 0.62 in the first one. Okay, and then here we have 0.0625 semi-annually, so twice a year, minus 1. Okay, find those two values and see which one is better. Here are the two values that I've calculated. So it seems like the investment at 6.2% compounded daily is a little bit higher than the one that's compounded semi-annually. All right, we have 6. Let's see, if we try to do 2 decimal places, the 5 will round the 9 to a 0, so this rounds up to 6.40%. And here we have 6.35%. So in this case, the number of times the interest was compounded was so much more frequently than in this situation on the left that it actually did make a difference, even though the rate was a little bit lower. Okay, one thing that you could do if you wanted to explore effective rates a little bit more, try to find some real examples. So check with your bank or maybe a couple other banks and see if you can do a couple comparisons. So find a couple savings accounts with different stated rates and different compounding periods, and then find the effective rates in order to compare and see which one is a better investment.